This first section of Chapter 2 is about patterns and inductive reasoning. Inductive reasoning is just reasoning based out of patterns you observe. So we're going to be looking at patterns today. So it says, look at the pattern, what are the next two terms in each sequence? So my sequence is 3, 9, 27, 81. Since the numbers are getting bigger, I would think about adding something or multiplying. So on the first case, if I were to add, I would have to add 6, but if I added 6 on the next case, it would not work. So then instead I look to multiply. It looks like we're multiplying by 3 every time. So the next two terms then would be 243 and 729. Pause the video and try the next one. On the next one, you have a circle on each one, and then I have a figure on the inside of the circle. The first one has a 3-sided figure, the second one has a 4-sided figure, the third one has a 5th-sided figure, so that means the next one needs to be a 6-sided figure, and then the last one needs to be a 7-sided figure. So you do your best in just drawing them. It doesn't have to be perfect. Alright, so then next, it might ask you to make a conjecture. A conjecture is a conclusion that you reach using inductive reasoning, meaning I'm going to look at a pattern and come up with an answer. So here's my first problem. It's asking me to look at the circles and decide what is the conjecture I can make about the number of regions for 20 diameters. So I look over here and I see that my first one has 1 diameter and splits it into 2 regions. The next has 2 diameters and splits it into 4 regions. The next has 3 diameters and splits it into 6 regions. So if I look at a pattern or something that's going on between those two numbers, it looks like it's just being doubled. So I could take the number diameters and double it. So in this case, if I had 20 diameters, I would just double it and get 40 regions. Alright, let's practice again with another one. Suppose it asks what conjecture can you make about the sum of the first 30 even numbers. So it does not give me the sequence, so I would need to write out my sequence. So I made a table. So I did the first even number, that's 2. And so the sum obviously is just 2. Then I did the next 2 even numbers, 2 and 4, added those and got 6. I did the next 3 even numbers, 2, 4, 6, added those and got 12. Then I just kept going and I did one more set where I did 2, 4, 6, and 8, and I added those and got 20. My job is to try and figure out a pattern, some kind of formula of some sorts, so that I wouldn't have to do this for the first 30 even numbers. So what I noticed is I could take 2 and do 1 times 2. To find 6, I could do 2 times 3. To find 12, I could do 3 times 4. To find 20, I could do 4 times 5. So looking at those factors amongst those, I realized that the first number could be the number of even terms or the number of even numbers that I used. So for example, this is 4 even numbers, so the first number is a 4. And then the second number, I would just add 1 to that. So then I would use 5. So I found that if I took the number of even numbers and multiplied it with the number of even numbers plus 1, I could find the answer. So since it's wanted me to find the first 30 even numbers, I would take 30 times 31, and so my answer would be 930. So sometimes they don't give you a sequence and you have to try and figure the sequence and then also find the pattern. So you're going to pause the video and try the next one. So on the next question, it asks you, what conjecture can you make about the sum of 2 odd numbers? So you would want to make your own sequence. So I went ahead and just started putting down some odd numbers. So I did 1 and 3, which is 4. I added 3 and 5, which is 8, 7 and 11, which is 18, and then I just started jumping around and I did 13 and 19. A conjecture is just a conclusion based off what you see. What I see is that all of those are even, so my conjecture is just that the sum will be even. So, if it's not asking me to actually find a numerical answer, such as this question, I just write a sentence describing my conjecture. Alright, the last part of this lesson is a counterexample. And a counterexample is just an example that makes my conjecture false. So let's look here. Wants me to find a counterexample for each conjecture. If the name of a month starts with the letter J, it is a summer month. So I'm thinking of all the months that start with J and seeing if there are any that are not summer months. Well, yes, January is one of those. So January starts with J, but it is not a summer month, so that's why it is a counterexample. Let's take a look at the next. You can connect any 3 points to form a triangle. I drew my picture in a straight line. So if I have 3 points in a straight line, then no, I would not be able to make a triangle because they would not have any kind of peaks between them. Pause the video and see if you can do the last one. So on the last one it says when you multiply a number by 2, the product is greater than the original number. My counterexample is using a negative number. Suppose I took -3 and I multiplied it by 2. That would be -6. According to this, -6 has to be bigger than -3. That is incorrect because when you're talking about negatives, this one would be smaller. So I wrote -6 is not greater than -3. So this first section is just finding patterns and coming up with conjectures based off those patterns, and then also being able to give a counterexample.